equations. Let's say we have an equation like this: log e 3x minus 2, that's equal to 5. What's the x value? Now we have seen in the previous videos, like when we have a log, we can actually bring to this side and equate that one to the other side. So this is basically e power 5, that is equal to 3x minus 2. From this one we can solve for x, that is 3x is equal to e power 5 plus 2, and then x is equal to e power 5 plus 2 divided by 3. That's our final answer for this one. And if you calculate this one using calculator, you're going to get something like 50.14, this approximate value. Okay, now let's look at another logarithmic equation. Let's say we have an equation given like 4 log 2x minus 1 plus 3, that is equal to 11. Now here we can simplify this plus 3 and 11. Let's do that first. So this is going to be 4 log 2x minus 1, that's equal to 11 minus 3, that is 8. 4 log 2x minus 1 and 11 minus 3, that's 8. And the next thing I can do is I can bring this 4 also to the other side. So that's going to give us a log of 2x minus 1 is equal to 8 over 4. Then log of 2x minus 1 is equal to 2. Okay, and log is basically log e. Log, if you expand this one, this is log e. So if we write this one in terms of, so there's a base of e right here, and this e I can bring to this side. If you watch my previous video, you will get an idea, like whenever we have base, we can bring it to the other side and make it an exponential equation. So that's what we are doing right here. We bring it to this side, so that's going to become e square, that is equal to 2x minus 1. Here we want to solve for x, so this is going to be 2x is going to be equal to e square plus 1, and then x is going to be equal to e square plus 1 divided by 2, and it divides the whole thing. Okay, or not only 2, whole thing. So it's going to be dividing by 2. That's our final answer for this question. Let's look at, and also if you want to find the approximate answer, you can plug it in the calculator. You will get 4.194, and that's our final answer for this question. Now let's look at another problem, another logarithmic equation. I'm going to erase the whole thing. Okay, let's look at that. So let's say we have an equation given like this: log 3 log base 3, and that log base 3 of 5x plus 2, that is equal to log base 3 of 7x minus 8. Whenever we have a base equal bases, it means the value here in the bracket is going to be whatever the value here is going to be equal both sides. So since we have log 3 like same base both sides, we can just equate them. So this is going to be just 5x plus 2 is equal to 7x minus 8. And if I bring x to one side, this is going to be 7x minus 5x. And if I bring the numbers to one side, this 2 plus 8. Therefore, we are getting 2x is equal to 10. Therefore, x is going to be equal to 10 divided by 2. That's equal to 5. Now let's, that's our final answer, x is equal to 5. Now let's look at another logarithmic equation. Let's say we have a logarithmic equation given like this: log 2 base 2 x square plus 4x, that's equal to log 2 of 5. Now here we have again same base, so we can equate the top part. So x square plus 4x going to be equal to 5. And here it seems like if I bring everything to one side, I can factor and solve it. So let's go ahead and do that. X square plus 4x, and if I bring 5 to this side, this is minus 5, and then that's equal to 0. And to factor this one, we have to have a value that's when we multiply, we have to get negative 5, and when we add, we have to get positive 4. So 5, okay, when we multiply, we have to get negative 5. When we add, we have to get positive. So positive 5 and minus 1 seems to be working, because when you multiply, you get negative 5, and when you add, you get positive 4 for this value. So we can say x plus 5 and then x minus 1, that's equal to 0. Therefore x plus 5 is equal to 0, and also x minus 1 is equal to 0. Therefore we can say x is equal to negative 5, and also x is equal to positive 1. Okay, that's it for this one. Now let's look at another problem. So these are the two answers, x is equal to negative 5 and x is equal to positive 1. Let's look at another logarithmic equation. I'm going to erase the whole thing. Let's say we have a question like this. Let's say we have a logarithmic equation given like log 2 of x plus log 2 of x plus 4, that is equal to 5. Now for this one, we have a same base, log 2, but the thing is we don't have log in the other side, so we cannot equate. There's another thing we can do. If you remember from my last video, there's a logarithmic equation like when we have two addition, let's say log a and log b, we can also express this one as multiplication like this within the square in the circle bracket, log a times b. So that's what we are going to do right here, because if we do that, we can simply solve this one. So to do this one, actually let's go and do it. So I'm gonna continue with this equation right here. So that is, we can also express this one as log 2 of multiplication of these two values, that is x times x plus 4, that's equal to 5. And if I simplify this one, this is going to be log 2, x times x is x squared, and then x times 4 is 4x, that's equal to 5. Now we are going to do the same thing we did before, that is, if we bring this base to this side, this is going to create an exponential function, exponential equation. The exponential equation gonna look like this: 2 power 5 is gonna be equal to x squared plus 4x. Let's go ahead and continue it right here. So x squared is 4x, x squared plus 4x is equal to 2 power 5. 2 power 5 is 32. And if I bring 32 to this side, because if you bring, I can factor and solve this problem. So to do that, I bring to this side x squared plus 4x minus 32. 4x minus 32 is equal to 0. Now we have to see, is there any value that when we multiply, we get negative 32, and when we add, we get positive 4. So 8 times 4 works, and it has to be positive 8, negative 4, because we had to get, when we add, we had to get positive 4, so the highest value should be positive. So here 8 is positive, and then minus 4. So we can also express this one as x plus 8 times x minus 4, that is equal to, x minus 4, that is equal to 0. I erase this one. Therefore x plus 8 is equal to 0, and also x minus 4 is equal to 0. Therefore x is equal to negative 8, and also x is equal to positive 4. But here we are not done yet. We have to do a check. Like whenever you place log 2 and a negative value like this, negative 8, you will get error. You can try it in your calculator, you will get error. So we are not going to get an answer for this. So in order for this one to be true, when we add this one and the negative log 2 of negative 8 plus 4, that's log 2 of 4. When we add these two, we have to get 5. That's the equation given. So it has to be satisfied. But when I plug negative 8, it doesn't satisfy that, because when I put negative 8, it's automatically error. So this value doesn't include. We cannot include this one. But you can try the other one. That actually going to give the value. Actually, let's go and try it. So if you plug 4 for this is going to be log 2 of 4. You know what? I'm going to erase this part to do that. Let's erase this arrow as well. Let's go and continue. Okay, so if I substitute 4 in this equation, that's going to be log 2 of 4 and then plus log 2 of 4 plus 4, that's 8. That's equal to 5. Now I'm going to just try to solve without a calculator. Let's see. You can just plug it in the calculator, you will get 5. But I'm going to try to solve this one without calculator. I can use this formula to simplify this one. So this is going to be log 2 of 4 times 8, that is 32. 32 right here, and that's equal to 5. Now you can see that 32 is 2 power 5, right? So we can write this one as log 2 power 5. And when we have base number and this number are equal, we can say that's equal to, we can cancel this, and this 5 comes to the front, right? So we are going to have 5 multiplied by 1. This log 2, if the base 2 and this the same, that's 1. So 5 times 1, that's 5. So therefore this one satisfies this equation. So the x is equal to 4 is our answer, final answer. And that's it for this video, guys. Thanks for watching. See you guys on my next video.